So today we are going to discuss various properties of exponents. So let's take, for instance, we have 7 times 7 times 7 times 7. That we know is 7 to the 4th because we have 4 factors of 7. Now we also can use the associative property. So say we rewrote this, but we wanted to group those together first. We wanted to multiply 7 times 7 times 7 and then multiply it times 7. So really, let's look at this. 7 times 7 times 7, that is 7 to the 3rd, and this is 7 to the 1st. But we know that 7 times 7 times 7 times 7 is already 7 to the 4th. What if we group this a different way? What if we said that we have this and we grouped these two and these two? So we have 7 times 7 and 7 times 7. Now we can rewrite this as 7 squared, and then we can write that as 7 squared. But we know that 7 times 7 times 7 times 7 is 7 to the 4th. So we have a rule with exponents. If you are multiplying the same base with different exponents, we can add the exponents together. So 7 to the 3 plus 1 power, because that's 7 to the 4th. We do the same thing here. 7 to the 2 plus 2 power, that's 7 to the 4th. So the rule is only when the bases are the same and you're multiplying them, you can add the exponents. So here we have 4 to the 2nd times 4 to the 5th. That is 4 to the 2 plus 5th power, which is the same as 4 to the 7th power. We can do the same thing with variables. A is our base, so we can add our exponents together. 12 plus 12, which is a to the 24th power. We can even do that with negative numbers too, with negative exponents, as long as the bases are the same. So if we just have 16 here, we know that that is the same as 16 to the 1st power. So now we have 16 to the 1, and then we're going to add a negative 7. Or 1 minus 7, that's the same thing. So we have 16 to the negative 6th power. And then here, 4 to the 2nd times 3 to the 2nd. We can't do anything with that. We cannot combine that because the bases are not the same. So don't get tripped up with that and do something funky with the bases. And it doesn't work that way. Okay. All right, so dividing with exponents. Let's look at 5 to the 5th divided by 5 to the 3rd. If I were to expand this out, 5 to the 5th is 5 factors of 5. And then I'm going to draw my dividing line. And then 5 to the 3rd is 3 factors of 5. Now, from what we know about fractions is when you have common factors in the numerator and the denominator, we can start canceling or dividing those off. So I can, at one at a time, cancel off factors of 5 because I am multiplying. Well, now I'm out of factors. So what I am left with now is 5 times 5 over 1. So here, 5 times 5 is the same as 5 squared. So look at what we did. We have a 5 and a 3, and we end up with a 2. What did we do? We subtracted these two exponents, and we kept the same base. Let's look at here. We can do the same thing. Keep the base, subtract the exponents, 7 minus 4. So we are left with 2 to the 3rd power. Remember, this is only when we divide. When we divide, we subtract. It's kind of like we use this. It's kind of correlated. This big line for dividing is the little line for subtracting. Do the same thing with variables. X to the 4th divided by x to the 1st. We have x to the 4 minus 1, which is x to the third, or x cubed. Now we have another one, x to the 4th divided by x to the 9th. We do the same thing. Don't worry if the one in the numerator is smaller than the one in the denominator. Same thing, same bases, x and x, and now we subtract 4 minus 9. And 4 minus 9 is negative 5. So we're left with x to the negative 5th. And finally, yes, we can take a power to a power.
Mrs. McKee, would you please call the office? Thank you.
So this is literally 5 to the 3rd, and we're taking that quantity to the 2nd power. So in other words, we have 2 factors of 5 to the 3rd because we are squaring it. Now, from what we learned over here, when we have the same bases and we're multiplying, we are adding the exponents. So this is 5 to the 3 plus 3, in other words, 5 to the 6th. But look at your original problem. How can we go from 3 to 2 and get 6? You guessed it. We are multiplying. When you take a power to a power, we multiply. So here, 7 to the 5th to the 3rd, we are going to multiply the exponents. 7 and then 5 times 3 is 15. You guessed it, we can do the same thing with negative numbers. 2 to the negative 7 to the negative 2, we have 2 to the 14th. A negative times a negative is a positive. And yes, we can multiply a positive times a negative. So we have x to the 10th to the negative 5th. 10 times negative 5 is negative 50. So when we multiply bases, the same bases with exponents, we add the exponents. When we divide, making sure we have the same bases, we're subtracting the exponents. And when we're taking a power to a power, we are multiplying the exponents. I hope you have fun with your exponents.